Hello friends, so let's talk about the assumption and residual plots for a two-way ANOVA. Let's return to ABC, which produces eye drops to relieve minor eye irritations. Its researchers have noticed that the product types are delivering different amount of liquid. Through various investigation of the data, it appears the company should switch to the product B for the current and modified eye droppers. Now that we have completed our evaluation, so how do we know our results are trustworthy? In earlier lesson on one-way ANOVA, we examined three assumptions and checked them using the residuals. If our model violates these assumptions, the results of the analysis can be misleading. The three assumptions are that the errors are random and independent, the errors are normally distributed, and the errors have constant variance across all combinations of factor levels. And this same method applies to two-way ANOVA. Let's consider the first assumption, randomness, and take a look at the plot of the residuals versus the order in which the data were collected for the ABC study. So do the residuals appear to be random and independent? You can see here the residual appears to be randomly distributed and no unusual patterns exist. Our second assumption is that the errors are normally distributed. We can evaluate this assumption by examining a normal probability plot of the residuals. In this plot, the residuals should generally follow a straight line. So do the residuals appear to be normally distributed? Because the residuals approximately follow a straight line, so which means that the residual follow a normal distribution. The third assumption is that the errors have constant variance across all combination of factor levels. To investigate this assumption, examine a plot of the residuals versus the fitted values. For a two-way ANOVA, the fitted values are the means of the factor combination or interaction. So the spread of the residual for all combinations looks similar. So this indicating that uh, the variance is constant across all combinations of factor levels. So let's review. We learned that there are three key assumptions about the errors for an ANOVA model. The assumptions are that the errors are random and dependent. The errors are normally distributed, and the errors have constant variance across all combinations of factor levels. If the model violates these assumptions, the results of the analysis can be misleading. We can examine the plots of the residuals to check the ANOVA assumptions. Thank you for listening. In the next lesson, we'll talk about the correlation and regressions.